The second half of the fifth unit, it is a DC to DC converters. Okay. So what is DC to DC converters means in EC1 you studied AC to DC converter and so on. Okay. This is a DC to DC converter. So it converts that is some amount of DC signal into some amount of DC signal. Okay. So it is said to be the DC to DC converters. Okay. And it is a power device. Okay, it's a power device. It handled with power. Okay, so the element the electrical devices. And this DC to DC converter, it is also called as DC chopper. Okay, DC chopper abdinalo, DC to DC converters abdinalo, it is same. Okay, same only. Okay, so we will see first the definition of the DC to DC converter. So what is DC converter means or DC chopper means? So the DC chopper, it is a high speed static switch. Okay, it is a high speed static switch and it is used to obtain the variable DC voltage from the constant DC voltage. If our input vandu maybe we given the input for this DC converter is some 5 volt. Okay, so this DC to DC converter, it converts the input 5 volt DC to, it may convert into some 7 volt, or the DC to DC converter, it converts the 5 volt into some 3 volt. Okay, so either it can increase the DC level of the particular input signal or it can decrease the DC level of the particular input signal. Okay, அப்போ ஒரு DC இன்னொரு DC convert பண்றதா it is called as the DC to DC converters. Okay, so and அப்ப நான் சொன்னேன் the input is 5 volt, so the output may be either 10 volt or 3 volt. அப்ப 10 volt அப்படின்னா என்ன மீனிங், input விட நமக்கு output வந்து it is high. Okay, அப்ப 3 volt அப்படின்னா the output is down. Okay, so that's why this chopper, okay, this chopper or DC converter, it can be considered as a transformer concept. Okay, in a transformer there are two types of transformer is there, either step down or step up. Okay, what is step down transformer? The output voltage is lesser than the input voltage, na it is step down. Okay, the output voltage is greater than the input voltage, na it is a step up. Okay, similarly this DC to DC converter, it can perform either step up the voltage or step down the voltage. Okay, so depending on that one, this DC to DC converter, it can be classified into 3 types. Okay, so these are all the 3 types of DC converters. So one is buck converter, another one is boost converter, the third type is buck boost converter. Okay, so what is buck converter means? It is a step down converter. Okay, apart from the name itself, the answer is that step down converter. What is the meaning? The output of the converter is less when compared to the input applied to that converter. Okay, so that is said to be the step down converter. So the step down converter is called as the buck converter. Then the second type is, it is a boost converter. Okay, so boost means namely answer boost. So it is a step up converter. So the output voltage is greater than the input voltage. So it is said to be the boost converter. And the third one is the combination of these two. That is buck boost converter. That is, it may be working as a either step up or step down. Okay, the same circuit will work as a step up converter or step down converter. So these are all the 3 types of converters. Okay, so we will see the what about the circuit diagram of this converter and how to, that is the analysis. Okay, what about the waveform, what about the working principle, we have to see one by one. Okay, then before that, the converter, so this is the basic diagram, the basic block diagram of the converters. Okay, so in order to, so that converter, it may be used as a switching mode regulators. Okay, so the converter, it consists of the 4 components. So one is, so this is the input, the unregulated DC input we are applying. This is our regulated DC output we will get. Okay, so within that one, what are the components we are using abdina? The first one is DC chopper. Okay, so this DC chopper, it is nothing but a switch. Okay, so we may use either transistor, that is BJT, or power MOSFET, and IGBT, the insulated gate field effect transistor, IGBT. இதுல எந்த devices வேணா நம்ம யூஸ் பண்ணலாம். Okay, so this DC chopper, it is nothing but a switch. Okay, so in order to work as a switch, we may use, in the place of DC chopper, we may use either BJT or JFET or MOSFET or IGBT. Okay, and in order to switch on and off this DC chopper, we have to give some control signal. Okay, so this is the control signal applied to this DC chopper. Okay, so then after that, So we have to use one feedback network. Okay, so in that feedback network, we may use one comparator section and one amplifier section. So this is the block diagram of switching mode regulator. So இது உங்களுக்கு தேவையில்லை இந்த block diagram, just explain பண்றதுக்காக தான் பண்றேன். ஓகேவா? So we have to use the working principle of this one. Okay, so first புரிஞ்சுதா? So what is DC to DC converter? It converts one type of DC into another type of DC. That is, the output of the DC converter may be either high, greater than the input DC voltage, or less than the DC input voltage. If greater than abdina, it is said to be the step up converter. If the output voltage is less than the input voltage, na, it is said to be the step down converter, that is buck converter. Okay, so same circuit, it will work as a both step up and down. It is said to be the step down, step up and down converter. Okay, so we will see one by one. So the first one, this is the buck converter. So in the mono converter kume buck converter, boost converter and buck boost converter, three kume vanda the components used is same. Okay, so what are the components we are using in order to construct this one abdina? So first we have to use DC chopper. Okay, so in the place of DC chopper, we have to use one transistor. Okay, transistor T1. So இதுதான் நான் சொன்னேன், this transistor, it may be a transistor, or it may be a MOSFET, or it may be a IGBT. எந்த ஒரு power devices நம்ம switch use பண்ணலாம். Okay, this is the transistor we are using. And in order to control this transistor, that is, in order to make switch on and off, we have to give some control signal to the base of the transistor. Okay, so this is the control unit. Okay, and the next one, we have to use one diode. Okay, this is the ordinary PN junction diode, and we have to use one LC filter. Okay, this is the inductor and this is the capacitor. So this LC வந்து the combination of the series inductor and capacitor, it will work as a filter. Okay, LC filter. And in order to take the output, we have to use one load resistor. Okay, we have to connect the load here. Okay, so எல்லா கன்வெர்ட்டர்லயுமே இதே காம்பனன்ட் தான் இருக்கும். One switcher, one control unit, one diode, inductor, capacitor and load. But position வந்து different இருக்கும். So based on the position, that circuit, it may be work as a either step up converter or step down converter or step up or down converter. Okay, so we will see one by one. So in this, so this is the input voltage. Okay, this is the input voltage applied to the buck converter. So output taken across this load, it is said to be the output voltage. Okay, output voltage. இப்போ நம்ம buck converter அப்படின்னா நம்ம என்ன proof பண்ணோம்? We are going to prove the output voltage V0. Okay, so buck converter means, you know, buck converter is a step down converter. A step down converter means the output voltage, the output DC voltage is less than the input DC voltage. அப்ப V0 equal to some fraction of Vs அப்படின்னு நம்ம prove பண்ணோம். So அது வந்து நம்ம analytically prove பண்ணலாம். Okay, so before that one, first we have to see the working principle. Okay, working principle. So in order to explain the working principle of this buck converter, so we are going to use the two modes. Okay, mode 1 and mode 2. So mode 1 means if the transistor is in on position. Okay, on position means what about the working principle of this circuit? And this transistor is in off condition. Okay, if this switch is in off அப்படினா, what about the working principle? இதே மாதிரி தான் எல்லா மூணு சர்க்யூட்டுக்குமே ஒரே மாதிரி தான் நம்ம ப்ரூஃப் பண்ணோம். புரிஞ்சுதா? And so first one, so you just assume that the control voltage applied to the base of this transistor is positive. So because of this is the NPN transistor, in base, if you are applying the positive voltage, means this transistor tends to be on condition. Correct? So this transistor tends to be on condition. So you know, the transistor tends to be on condition means this transistor, it is acting as a short circuit. Correct? On condition and others. This is switch ஆ தான் நம்ம யூஸ் பண்றோம். அப்ப switch வந்து என்ன position? It is in closed position. அப்ப this transistor is in closed position means, so the next one, after this transistor, if this transistor is in closed position means, what about the position of this diode? You see the diode anode is connected to ground. Okay, cathode is connected to here. Okay, here. அப்ப இந்த diode வந்து either it is a forward biased or reverse biased during this is short circuit condition means, அப்ப இது short circuit அப்படின்னா நம்ம இங்க அப்ளை பண்ற Vs voltage, the input voltage டைரக்டா இங்க வரும். கரெக்ட்டா? அப்ப நெகட்டிவ் டெர்மினலுக்கு நம்ம பாசிட்டிவ் வோல்டேஜ் அப்ளை பண்ணோம் அப்படின்னா, வாட் அபவுட் தி பொசிஷன் ஆஃப் டயோட்? த டயோட் கெட்ஸ் ரிவர்ஸ் பயாஸ். ஓகே, so that's why in mode 1 operation, during this transistor is in on condition, this diode gets reverse bias. So you know, if the diode gets reverse bias அப்படின்னா, what is the meaning? the diode it is working as a open circuit. Correct? அப்ப இந்த diode வந்து it is working as a open circuit. Okay. அப்ப open circuit means but here where is the closed path? So the closed path is forming from this is the input voltage, then inductor, capacitor, and this one. But because of this input DC voltage, so there is a current. Okay, source current is flowing through this circuit. Correct? But in the source current, this source current is flowing through this inductor. Okay, and after that inductor, in this node, we are having the two branches. Right? Two branch. One is this capacitor, another one is load. Some portion of current is flowing through this capacitor and the remaining current is flowing through this load. Okay, so here we are considering current flowing through this load is I0, current flowing through this capacitor is IC, current flowing through this inductor is IL. Okay, this total current is we are calling it as a IS. Mention paniko. Because during this condition, so the current is flowing through this one. Correct? At that position, what about the inductor? Inductor that is, you know the concept of inductor. Okay, resistance la mattuna nama voltage apply pannom appadina the current flowing is suddenly increase agum. Okay, constant current flow. But in the case of inductor and capacitor, the current flowing is slowly increasing. Okay, but during that condition, the current flowing through the inductor it is increases from some I1 value to I2 value. Correct? I2 value. Okay, adha nyabagam vechukonga. And in this case, so what is the voltage across the inductor? So in the inductor across enna voltage irukum? Ipo idhukku vandu nama this circuit idu oru closed loop. But for this closed loop, we may apply KVL. Okay, appo you just apply KVL. This is one closed loop. Appo you apply KVL. What is Kirchhoff's voltage law? In any closed path, the algebraic sum of voltages is 0. Illa appadina என்ன சொல்லலாம் அப்படின்னா the sum of voltage rise equal to sum of voltage drop. Okay, அப்ப if you are considering here minus to plus, so this Vs is a voltage rise. So Vs equal to voltage across the inductor we are considering as VL, and voltage across the capacitor. You see the capacitor and load parallelly connected. So அப்ப parallelly connected அப்படின்னா voltage across the capacitor தான் voltage across the load. So we are considering voltage across the load is V0. Correct? So the voltage across the capacitor is also equal to V0. If you are applying KVL, we get Vs equal to VL plus V0. Okay, from this voltage across the inductor VL can be written as Vs minus V0. Okay, this is the value in the mode 1. Correct? You see the transistor T1 is turned on by applying the base signal from the control unit. The control unit apply the transistor is in on condition. So at the time, the diode D gets reverse bias. So that's why the current flowing through the switch, inductor, capacitor and load. Okay, so because of that one, the voltage across the inductor, it can be written as Vs minus V0. Okay, this is the mode 1 operation. And in this case, the current flowing through the inductor increases from I1 to I2. That is minimum value lende I2 varaiku namakku enna current vandu increase agum. Okay, this is the mode 1 operation. Then mode 2 operation. So what is mode 2 operation means? So for the particular time, the time t equal to t1 க்கு முன்னாடி வரைக்கும் தான் நம்ம என்ன பண்றோம் அப்படின்னா the voltage applied to the base of transistor is positive. Okay, at the time t equal to t1, the base signal applied to the transistor is 0. Okay, அப்ப 0 கொடுத்தோம் அப்படின்னா what about the transistor? The transistor becomes this transistor in the base ல வந்து previous positive கொடுத்தோம், so this is on condition. Now we are applying 0 voltage. 0 voltage apply pannom appadina what about the transistor? The transistor gets reverse bias. Okay, but this transistor it will act as a open circuit. But this transistor it will act as a open circuit means, so the equivalent diagram you see this transistor it gets open circuit. Open circuit means there is no connection between the input and output. Correct? There is no connection between the input and output. Here now this diode D gets forward bias. Okay, ஏன்னா இங்க இருக்க voltage வந்து it is less value, so the diode gets forward bias. So this is the equivalent diagram of this one under mode 2. That is if you are applying 0 voltage at the base of the transistor. Okay, now there is a closed path is there. Okay, so previously this inductor, that is inductor and capacitor is a energy storage element, you know. Okay, அப்ப நம்ம வந்து நம்ம அப்ளை பண்ற இன்புட் வந்து ஈவன் தோ ரெடியூஸ் பண்ணாலும் என்ன ஆகாது நமக்கு the current flowing through the inductor does not reach a 0 value suddenly. Okay, So we will get the transient currents, correct? So the current flowing through the inductor now decreases from the maximum value I2 to I1, correct? But during this period, the current flowing through the already the previous nala namakku inga current evlo current flow aayittu irundhuchu I2 current. So that I2 current decreases to I1. Okay. But that current is flowing through this capacitor and load. Okay. Now what is the voltage across the inductor means? You see, apply KVL to this in the L is C. Okay, this is a closed path. In the closed path, you just apply KVL. If you are applying KVL, the VL equal to what is the value? Minus V0. Correct? VL, that is VL plus V0 equal to 0. VL equal to minus V0. So voltage across the inductor is minus V0. Okay. During the two condition, we derived the values. Okay. Let us see the voltage and current waveform of buck converter. So enna voltage and current போட்டுக்கோனா VL ங்கிறது load கிடையாது, inductor க்கு across இருக்க voltage. Okay, here load க்கு across இருக்க voltage வந்து the output voltage V0 and current is I0. Okay. Voltage across the inductor is VL. Current flowing through the inductor is IL we are considering. Here we are drawing voltage across the inductor and current flowing through the inductor. Okay, first paranga during this time. Okay, during this time the transistor T is in on condition. Transistor T is in on condition இருக்கும்போது what about the voltage across the inductor? We derived Vs minus V0. It is mode 1. இதற்கா derive பண்ணிக்கோமா? The value of VL equal to Vs minus V0. And what about the current flowing through the inductor? It increases from some minimum value I1 to I2. You see, during this time, the voltage across the inductor is constant, whose value is Vs minus V0. And what about the current? This is the IL. So the current flowing through the inductor, it increases from some I1 to I2. Correct? This is the time T1. In the point is T1. At the time T equal to T1, we are applying the base signal of the particular switch is 0. 0 vachna the switch enaiche, that switch T gets open circuit. At the time, what about the voltage across the inductor? It reaches minus V0. The voltage across the inductor in the Vs minus V0 la sudden namakku enna appadina it reaches the minus V0 value. Correct? At the time, what is the current flowing through the inductor? Ena in the time la nama no input apply பண்ணல, previously இருந்த இந்த current தான் நமக்கு என்ன ஆகுது, exponentially discharge ஆகுது. So that's why the current flowing through the inductor is it decreases from I2 to I1. Okay, it current decreases from I2 to I1. Okay, இதுதான் வந்து ஒரு complete operation. Okay, after that இதுக்கு அப்புறமா again நீங்க வந்து that switch the transistorக்கு வந்து நீங்க baseல high voltage கொடுத்தீங்கன்னா again mode 1 operation. mode 1 operation minus V0 ல இருந்து voltage வந்து maximum ஆகும், current வந்து I1 ல இருந்து I2 க்கு increase ஆகும். இதே மாதிரி நமக்கு மாறி மாறி வரும். This is said to be the buck converter. புரிஞ்சுதா? So this is the voltage and current waveform of buck converter. Okay, and so from this converter இப்ப நம்ம இங்க waveform வந்து நம்ம என்ன போட்டுருக்கோம்னா output voltage draw பண்ணல, we are drawing the voltage across the inductor and voltage across the capacitor. Okay, so from the voltage and current waveform, so we are going to derive the output voltage. ஏன்னா நமக்கு வந்து நம்ம என்ன prove பண்ணோம், this இது வந்து என்ன converter? Buck converter. What is buck converter? It is a step down converter. Step down converter na what is the meaning? The output voltage V0. இதற்கா prove பண்ணிக்கோமா, the output voltage V0 is equal to alpha into Vs. Vs is a applied input voltage. இங்க ஆல்பாங்கிறது வந்து ஒரு fraction. Okay, the output voltage V0 is equal to some fraction of Vs அப்படின்னா என்ன ஆகும், நம்ம அப்ளை பண்ற இன்புட்டை விட அவுட்புட் வந்து ரெடியூஸ்டா கிடைக்கும். ஓகே, சோ இத வந்து நம்ம அனாலிட்டிக்கலா we have to prove. கரெக்ட்டா? We are going to prove. So it is a simple expression only. Okay, so how to prove this one means, so first we have to take so we know that the voltage across the inductor code general formula you know. Okay, so what is the voltage across the inductor? The VL can be written as L into di by dt. This is the general formula for the voltage across the inductor. VL equal to L into di by dt. Okay, if here the voltage across the inductor during this time amplitude higher இருக்கு, இந்த டைம்ல amplitude வந்து some different value minus V0. Okay, அப்ப இந்த இதுக்கான நம்ம ரிலேஷன் எழுதணும். கரெக்ட்டா? அப்ப now we have to write during the on period. Okay, on period of the transistor the inductor current rises linearly from I1 to I2. கரெக்ட்டா? இந்த பீரியட்ல இந்த transistor வந்து ஆனா இருக்கும்போது the current increases from I1 to I2. But here, what is this DI? DI is rate of change of current flowing through the inductor. அப்ப இந்த DI இருக்க பிளேஸ்ல நம்ம என்ன போடலாம்? That is DI is rate of change. அப்ப rate of change the maximum value minus the minimum value. அப்ப what is the maximum value attained by the inductor? I2. What is the minimum value? I1. அப்ப this DI it can be written as I2 minus I1. இப்ப இந்த I2 minus I1 எப்ப நடந்துச்சு? DT எந்த டைம் நடந்துச்சு? Rate of change of time. During எந்த டைம் இந்த I1 ல இருந்து I2 க்கு சேஞ்ச் நடந்துச்சு? During the on time. Okay, அப்ப instead of this DT we have to put T on. Correct? We have to put T on. புரிஞ்சுதா? அப்ப L into instead of DI I2 minus I1 instead of DT we have to put T on. Okay, and left side. What is left side? VL. What is the value of VL during this on period? அப்ப இந்த on timeல what is the value of voltage across the inductor? Vs minus V0. அப்ப what is the value of VL? Vs minus V0. அப்ப for left side instead of this VL we have to put Vs minus V0. So Vs minus V0 equal to L into I2 minus I1 divided by T on. Okay. அப்ப from this நம்ம என்ன find out பண்ணோம் அப்படின்னா we have to find two equation. Okay. One is T on equal to என்ன அப்படின்னு ஒரு equation. அப்புறம் இந்த del I equal to என்னன்னு ஒரு equation. இதே இதுல just rearrange பண்ண போறோம். அப்ப from this if you want to find T on அப்படின்னா இந்த T on இந்த சைடு கொண்டு வந்துங்க Vs minus V0 கீழே கொண்டு வா denominator. So from this T on equal to L into del I divided by Vs minus V0. Right? அப்ப from this if you want to find del I இப்போ இது A அப்படின்னு நான் சொல்றேன். அப்ப del I யும் find பண்ணிக்கோ. அப்ப from this del I வேணும்னா இந்த Vs minus V0 இங்க multiply பண்ணிட்டு L வந்து divide பண்ணிக்கணும். So this del I you have to consider as a equation number 1. Right? What is this del I? This del I as a difference between this I2 minus I1. இந்த I2 minus I1 தான் நம்ம ஷார்ட்டா வந்து del I அப்படின்னு கன்சிடர் பண்ணிக்கோம். Okay, del I equal to I2 minus I1. That is the difference between the current flowing through the inductor. Okay, this is the equation number 1. இப்போ இந்த equation number 1ங்கிறது என்னன்னா during on period, that is mode 1ல இருக்கும்போது, that is transistor onல இருக்கும்போது அந்த inductor currentக்கு நம்ம ஒரு equation எழுதிருக்கோம். Okay, similarly we have to write one more equation during this off time. Okay, அப்ப during this T off, what is the current flowing through the inductor? The current decreases from I2 to I1. At the time, what is the voltage across the inductor? Minus V0. Correct? But if you are writing one more equation for this T off அப்படின்னா T off நம்ம எழுதணும் அப்படின்னா we get. So இங்க பாருங்க during the off time the inductor current falls linearly from I2 to I1. அப்ப we will get, so what is the value of VL minus V0? So which is equal to ஏன் இங்க minus L போட்டுக்கோனா actually இங்க equation வந்து L into I1 minus I2 divided by T off ன்னு வரும். நம்ம வந்து del I ன்னு எதை வச்சிருக்கோம்? I2 minus I1 தான் del ன்னு வச்சிருக்கோம். அப்ப இங்க என்ன வரும்னா minus del I. கரெக்ட்டா? அப்ப minus V0 equal to minus L into del I divided by T off. அப்ப from this you just find out the value of T off and one more இதுல இருந்து rearrange பண்ணி இந்த del I கண்டுபிடிச்சுக்கோங்க. Okay. அப்ப from this we are having two del I value. Okay, the equation number 1 is 1 del I in terms of T on. Equation number 2 is del I in terms of T off. அப்ப இந்த two equation என்னது left hand side same. அப்ப நம்ம என்ன பண்ணலாம்? இந்த two equation equate பண்ணலாமா? Okay, அப்ப you just equate the equation number 1 and 2. Okay, அப்ப if you are equating the equation number 1 and 2, you see del I equal to V0 T off by L, this one. Okay, அப்ப in both the term this L cancelled. அப்ப the numerator V0 T off equal to Vs minus V0 into T on. இதுல இருந்து what is our aim? Our aim is to find out the value of V0. So rearrange பண்ணுங்க, இதை split பண்ணுங்க. So split பண்ண Vs T on minus V0 Tn. So V0 Tn இந்த side கொண்டு வந்துடு, ஏன்னா இங்க ஒரு V0 இருக்குது. So in the term you take V0 as common. So what is T on plus T off? It is a total time period. Correct? அப்ப total time T ன்னு வச்சுக்கலாம். அப்ப from this V0 equal to Vs T on divided by T. So what is V0? Output voltage of the buck converter. What is Vs? Input voltage applied to the buck converter. So இதுவும் DC தான், இதுவும் DC தான். And so this Vs multiplied with one ratio. What is this ratio? T on divided by T. T on another on time. T another total time. So நீங்க படிச்சிருக்கீங்க இல்லையா, ஒரு ஸ்கொயர் வேவோ எந்த வேவுக்கும் the ratio of on time divided by total time, it is said to be the duty cycle. Okay, இப்போ இந்த duty cycle we are calling it as a we have to make it as a one parameter or a constant alpha அப்படின்னு வச்சிருக்கோம். Okay, so usually what is the value of this alpha? Alpha greater than 1 வருமா? கிடையாது. Alpha is always less than 1. Okay, since the T-on is always less than T. Correct? You see the waveform? பாருங்க, இந்த total time T-on யும் T-off-யும் add பண்ணா நமக்கு கிடைக்கிறது தான் T. அப்ப the ratio of T-on divided by T வந்து it is always a factor. Okay, அப்ப you just consider as if T-on is 1 millisecond, T-off is 1 millisecond அப்படின்னா the total time is 2 millisecond. அப்ப what about the ratio alpha? 1 milli divided by 2 milli. அப்ப what is the answer for alpha? 0.5. Okay, so compulsory this alpha must be a it is a point, that is fraction value. Okay, apart from this equation we can say that the output voltage of this buck converter is always less than the input voltage. Correct? Appa if you are applying input voltage 5 volt அப்படினா நமக்கு வந்து alpha வந்து 0.5 ஆ இருக்கும்போது what about the output voltage? We will get half, that is 2.5 volt. Correct? அப்ப நம்ம input 5 volt கொடுக்கிறோம், we will get the output is 2.5 volt. So that's why this converter it is called as the step down converter. Okay, this is the thing. Okay, இதான் derivation. இதே மாதிரி தான் நம்ம அடுத்த 32க்குமே பண்ண போறோம். Okay, it is easy one. So என்ன அப்படின்னா first one we have to write the general voltage across the inductor VL equal to L into di by dt. Okay, அப்ப we have to write the two equation. One is during the on period, another one is during the off period. So but during the on period, so you see the inductor current is increases from I1 to I2. அப்ப the rate of change of current is I2 minus I1. Okay, எந்த time நடக்குது? During the time T on. So that's why the di இருக்க placeல I2 minus I1, dt இருக்க placeல T on. Correct? And at the time what about the value of voltage across the inductor? It remains constant, it is Vs minus V0. Correct? இது ஒரு equation. இப்ப இதுல இருந்து we have to find T on க்கு ஒரு formula, del I க்கு ஒரு formula. அதே மாதிரி during the off period of the transistor அதே மாதிரி ஒரு equation எழுதுங்க. அதுல இருந்து T off கண்டுபிடிச்சுக்கோங்க, del I கண்டுபிடிச்சுக்கோங்க. Then we have to equate this to del I. இந்த del ஐயும் இந்த del ஐயும் equate பண்ணோம் அப்படின்னா equate பண்ணி we have to find the formula for the output voltage in terms of input voltage. Okay, this is the thing. And another one, if we want to find this total time period, இப்ப இந்த total time period உங்களுக்கு வேணும் அப்படின்னா what is the total time period? It is addition of T on plus T off. Correct? So T on plus T off. So the time capital T equal to T on plus T off. Okay, அப்ப the T on value இங்க இருக்கா? We derived this is the T off value and this is the T on value. So two value just add பண்ணுங்க. Okay, இப்ப add பண்ணோம் அப்படின்னா we will get the total time. If we want to find the frequency உங்களுக்கு வேணும்னா but frequency is nothing but 1 divided by T போட்டீங்க அப்படின்னா we will get the frequency of oscillation. Okay.